In this video, I am going to go over two examples of how to use the kinematic equations for one dimension horizontal motion. In this video, we are going to do problems where we are going to solve for acceleration, and this is the first example. Number one says we have particles who accelerates from rest to a speed of 7.15 meters per second over a distance of 37 meters, and we want to know what is the acceleration of that particles. All right, now the first things you should always do is write down what you are given and what you are trying to solve for the knowns and the unknown. Now, as I said in this previous video, there are 5 different variables in the kinematics equation, and you should write down all 5 of them. Initial velocity, the final velocity is the change in the position, the acceleration, the time. Write down all 5, fill in what you know and what you don't know. We know that particles accelerate from rest. That means the initial velocity is 0 meters per second. The final velocity 7.15, and the distance over which they occur in 37 meters. That is the change in position. Now, we are trying to solve for the acceleration for input equations for where we have not given the time of. I am not going to try and solve for the time, therefore we are not going to use the time in this problem. Now you can see we are given 3 variables. We are trying to solve for the force. Get your kinematic equation. You should remember in each kinematic equation there are 4 variables. If you are given 3 and you can solve for the force, so we need to find the equation that has the acceleration in it and also has these other 3 variables. I am going to through each one at a time. The first equation does not have acceleration, we know, therefore we cannot use the equation. The second equation has acceleration in it, therefore we can use this equation if we know the other 3 variables. Do we know the other 3? We know velocity, yes, we know the initial velocity, yes. Do we know the time? Now we do not know the time, therefore we cannot use the equation. The next equation we are looking for the acceleration, so we have the do know variable with the change in position, the initial velocity, but once again we do not know the time, so we cannot use that equation. The last equation we are trying to solve for acceleration, it has the acceleration in it. We know the final velocity, we know the initial velocity, we know the change in position. This our equation. Let's take our information and the equation to the next. Now we can plug the values in and simply solve for the acceleration. Now we should notice also we can simplify this a little bit. Here we have the initial velocity square. Will the initial velocity square or the initial velocity is 0, and therefore the initial velocity square is also going to 0, so we can make this term 0. This term goes to 0. Now we have the final velocity is equal to 2 times the acceleration times in change in position. I'm going to rechange this equation, solve for the acceleration. That means the acceleration equal the final velocity squared divided by 2 times the change in position. The value in the final velocity squared is 7.15 squared divided by 2 times 37, and you get the acceleration of that particles is 0.69 meter per second square. That is the example number 1. Our second example of solving for acceleration, the car is traveling with the velocity of 32.7 meters per second. It decreased accelerate uniform to velocity of 16.5. Now you will notice it is slowing down, change the velocity is still called acceleration, so it does not say acceleration here, but you should not notice that it's slowing down, okay? and occur over time of 2.85 seconds. And we would like to know what is the acceleration. Once again, you should, the first step to solving this problem is to write down all 5 kinematic equations. Just write them all down. Get in the habit initial velocity, final velocity. Write down what you know. We know the car is traveling with the velocity of 32.7 meters per second. That our initial velocity. 16.5 is our final velocity, the time or which occurs 0.85 seconds, and we are trying to find the acceleration. We are not going to change in position. Now, once again, you will notice we have 3 variables or solving for get or kinetic equation. Let's see which equation are you going to use. The first equation does not have acceleration in it. Where we're going, acceleration, and it is just here. Our solution, do we know the other 3 variables? The final velocity, yes, the initial velocity, the time. So therefore we can use these 2 equations. Now just quickly, you will notice that these 2 equations have changed in position. We don't know the change in position, and therefore we could not use this either of these 2 equations. On the next slide, let's bring information in our equation. With this is the information that we are going, these 3 variables we are solving for the force. This is what we are solving for now. The variable, I like to rechange this equation first of all and solve for the acceleration before I plug the value. This means that acceleration is equal to the final velocity minus the initial velocity. Subtract the initial velocity from each side of equation divided by the time, and that our standard equation or standard definition of acceleration, change in velocity over time. Plug the value in, you get 16.5 minus 32.7 divided by 2.85 seconds, and you get the acceleration of that car is minus 5.68 meters per second. The minus sign tells us that is showing down. We can assume we kind to make the assumption that the motion of the object is in the positive direction, and positive velocity in negative acceleration means the object is slowing down or its speed is decreasing. So there you go. Those are 2 examples are using the kinematic equations to solve problems for acceleration. You will notice did the same steps for both. I wrote down all 5 variables. I filled in what we know, what we didn't know. We were given 3. We want to solve for the force. I showed the right equation. I rearrange for the variable. We solve for the plug value and get the correct answer with the correct units. Okay, thank you very much for watching. I hope you found that helpful. I will place some links here at the end of the video to some additional kinematic problems that you can use for some further practice. I hope you found helpful. If you did, you can please do all of the following 3 things. Give me thumbs up, leaving nice positive comments.